What if the object racing through our solar system right now isn't a comet at all? When astronomers turned their telescopes toward 3I/Atlas, the third interstellar visitor ever seen from Earth, they expected a faint, icy traveler shedding dust like countless comets before it. Instead, what they witnessed was something no natural object should display: a luminous tail stretching like a weapon, sharp, steady, and precise, almost as if it were under control. And that was only the beginning of the mystery. Comets are supposed to be messy. Their tails form when frozen gases erupt into space, spraying out in random bursts as solar radiation tears them apart. The result is usually a tangled plume, bent, twisted, and constantly shifting. But Atlas defied that rule. Its tail wasn't chaotic. It wasn't fragile. Instead, it stretched outward like a glowing spear, clean and sharply defined, as if drawn with purpose across the sky. This wasn't just a faint trail of ice sublimating into vapor. Each stage of its growth looked deliberate, almost mechanical, lengthening with the consistency of an exhaust plume rather than the erratic jets of a crumbling comet. For an object born in another star system, this level of precision was anything but simple. And it raised a question astronomers have avoided voicing for centuries. What if this isn't just nature at work? When NASA's James Webb Space Telescope turned its gaze on Atlas, scientists expected confirmation of the strange tale. What they got instead was a puzzle no model could solve. Webb detected an enormous plume of carbon dioxide erupting from the comet, so vast it stretched nearly 350,000 kilometers into space. To put that in perspective, that's almost the distance between Earth and the Moon. Yet even at that scale, the plume made no sense. By every calculation, the solar wind should have confined the gas long before it spread that far. And still, the material pushed outward, expanding past the limits of physics as astronomers understood them. But here's the catch. While the plume was far too large to be normal, it was still far too small to explain the comet's razor-sharp path toward Mars. Normally, violent outgassing like this would throw a comet off balance, wobbling its orbit with every burst. But Atlas remained locked in place, steady and unwavering, as if guided by an invisible hand. Webb's instruments told two stories at once: chaos on the surface and impossible stability in its orbit. And that contradiction left scientists with a chilling thought. Maybe this wasn't just a comet behaving strangely. Maybe it was something else entirely. If the strange tail and the giant plume weren't enough, the next revelation forced astronomers to rethink everything they thought they knew about Atlas. Recent studies of the comet's nucleus showed that its unusual brightness wasn't caused by exotic ices or reflective dust. Instead, it was shining because its surface contained nickel, metallic nickel, in concentrations far beyond what nature should deliver. Nickel isn't just reflective. It's strong, resistant to corrosion, and commonly used by humans to build machines, spacecraft, and protective plating. Yet here it was, covering the surface of an object supposedly drifting between stars for millions of years. No other comet ever observed has displayed this kind of metallic shell. To some, it was a simple oddity. To others, it was the first unmistakable sign that Atlas might not be a comet at all. Because nickel explains more than just the brightness, it explains the stability. A fragile icy body should crack apart under the violent stress of outgassing. Its spin should shift, its orbit should wobble. But Atlas doesn't fracture. It doesn't tumble. Instead, it glides forward with eerie precision, as if its core is reinforced, locked in place by design. And that possibility fuels a suspicion that refuses to go away. Perhaps what we're seeing is not a comet, but a machine wearing a comet's disguise. Measuring the heart of a comet should be simple. The nucleus is just a lump of ice and rock hidden beneath its glowing coma. But Atlas refused to fit the math. Hubble's early readings suggested the nucleus could be as small as 1,000 feet across, maybe up to 3.5 miles. Ground-based telescopes, however, hinted at something much larger, possibly 12 miles wide or more. That difference isn't a minor error. It's a staggering gap. If the nucleus were truly small, it should appear faint, lost behind the bright haze of its coma. Instead, Atlas reflects light at levels far too strong for its supposed size. But if the nucleus were closer to 12 miles across, it should wobble violently as gas jets erupted from its surface. And yet it doesn't. Its trajectory remains unshaken, smooth, locked into an almost perfect path. It's as though Atlas is both brighter than it should be, and more stable than physics allows. For a natural comet, that paradox shouldn't exist. But for a reinforced structure, something built to withstand stress, it starts to make sense. And that stability matters for one chilling reason. The path it's on leads terrifyingly close to Mars. October 2025. That's when Atlas makes its closest approach to Mars. A near miss on a cosmic scale. Astronomers calculate it will pass just 29 million kilometers from the planet. To the average person, that sounds like a safe distance. But in orbital mechanics, it's like threading a needle from across the galaxy. What unsettles scientists most isn't just the closeness, but the precision. Interstellar objects don't usually carve such exact paths. They're pulled by gravity after wandering for light years, tumbling into the solar system with chaotic orbits. Yet Atlas is different. Its trajectory is sharp, fine-tuned, almost as if aimed. A dart hurled across an ocean that somehow grazes the edge of a bullseye. NASA isn't taking chances. The Mars Reconnaissance Orbiter, equipped with HiRISE, one of the most powerful space cameras ever launched, will be watching. At 30 kilometers per pixel, it could finally pierce through the haze and reveal the nucleus in unprecedented detail. For the first time, humanity might see the true face of Atlas. And that's where the unease deepens. Because if the object shows even a trace of structure, even a hint of something engineered, then every assumption about its nature will shatter. But that's not the only possibility keeping scientists awake at night. Because if Atlas changes its course, even slightly, before October, it won't just challenge our understanding of comets. It will prove we're dealing with something that can steer. And that would change everything. The clock is ticking. On October 30th, 2025, Halloween Eve, Atlas will sweep past the Sun at its closest approach. Just days later, it will blaze by Mars, a cosmic visitor lighting up the skies of two worlds at once. For astronomers, this is a once-in-a-lifetime chance to study an interstellar object up close. But for others, it's something far more unsettling, a test that could reveal whether Atlas is natural or something built with purpose. If the comet holds steady, burning brightly but following its projected path, it will be remembered as one of the most spectacular natural events in modern astronomy. But if it adjusts course, even by a fraction, it will break the last defense skeptics have. Outgassing cannot explain a maneuver of that magnitude. Only control can. And that would mean Atlas isn't just a comet drifting through space. It's a craft, moving with intent. Some scientists whisper that its glowing tail might be more than a disguise. A halo expanding outward, bright enough to blind telescopes, hiding smaller probes within its haze. If that's true, then Atlas may not be traveling alone. It could already have scattered hidden objects, invisible to Earth's instruments, riding toward Mars, or even toward us. As the date approaches, tension builds. Politicians are openly urging NASA to watch Atlas with every tool available. Researchers are running models that leave them with more questions than answers. And the public is left staring at the sky, waiting for October. Because when the sun blazes behind Atlas, and when HiRISE turns its eye toward the comet, one of two truths will emerge. Either we are watching ice melt in the void, or we are witnessing the first undeniable trace of non-human technology. Until then, Atlas races forward, its tail glowing sharper, its course unwavering. A silent messenger from the stars, carrying a question humanity has never been closer to answering. Are we alone?